All right, so we've looked at shifts of a function, right? Shifting it up or down, or right or left, right? Vertical and horizontal shifts. We also just looked at reflections of functions, right? Reflecting it across the x-axis or the y-axis. And now we're going to look at vertical stretches and compressions. So I think of vertical stretches and compressions as just being like turning up the volume or turning down the volume. Turning up the volume increases the signal, which increases the sound pressure in your ear. But zero is still zero, right? So it's a multiplier. And the same way with compressions, we're just multiplying by a factor that's less than 1 when we turn down the volume. All right, so let's take a look at this first example. We have the function f of x in the graph, and we're asked to sketch the following transformations. So the first one, we're just looking at 2 times f of x. So we're taking the output of f of x and multiplying it by 2. All right, so if we have any xy pair, that we take the output of the function f of x and multiply by 2. So for example, here we have the point 0, 0, right? If we multiply by 2, it's still 0. So that point is still on the graph of 2 times f of x. But if we take a point like 2, 3, right? When x is 2, right, then f of x is 3, but 2 times f of x is going to be 2 times 3, which is 6. So now that point gets multiplied by 3. The output of the output for the input of 2 gets multiplied by 3, and now that point is on the graph. And we can take any point on the graph. So for example, it looks like here, I don't know what the x value is, but the y value is 2, so that's going to go straight up to 4, right? This is 1, and it's going to go to 2, right? Because we're just multiplying the output, right? We're not changing the input, we're just multiplying the output, right? So this looks like maybe, so this, yeah. So, so we can just take each point, multiply by 2, and then we're going to connect it with a curve. So let's see how well I can connect this with a curve. You get the idea. I'm just going to connect the dots, and you can get an idea of what the new function would look like, right? This y equals 2 f of x. All we've done is take every output and multiply it by 2 for the same input. Turned up the volume on the function. All right. Now here we're multiplying by a half, right? So now we're going to take the output of the function and take half of it, right? So now again, 0, 0, right? When f of 0 is equal to 0, so half of f of 0 is still 0, right? So that's fine. If we take, though, half of f of 2, that's half of 3, and so we have 3 halves, so 1 1/2, right? So just taking half of it. So 1 1/2 is about here. All right, and we can do that for each point. Just take half of it. So here's 2, and that's going to become 1, and then here 1 is going to become a half. All right, so I've got a few points here, and I can just sort of connect them with the curve. And now I should have used a different color, but oh well, it's done now. I'm not going to take time to do it in a different color. But this is the function. This is 1/2 of f of x, right? That's that. I'll label these. This was 2f of x. All right. Now one more here. We're going to look at the multiplying the function by a -2. All right. But again, we're just taking the output of the function and multiplying by 2. So for 0, 0, the output's still 0. But if we take the 2, 3, we're going to multiply 3 by -2, and we're going to end up at -6. So let me scroll down just a bit. And so we're going to end up down here. Okay. So, and we're just multiplying by -2. And, we can do that for any point. So for example, I see this point right here is about at 2, right? So if we multiply that by -2, we're going to be at -4. So we're going to have a point about here. Here we're at 1. The y value is 1 for somewhere around 6.5, right? So I can come down here and it's going to be a -2. Okay. So it's basically the reflection of the part A across the x-axis. So let me just connect this up and you get the idea. It looks something like that. All right. So this is -2 f of x, -2 times f of x. All right, we just think of it as turning up the volume or turning down the volume. All right, so if you look at this function diagram, essentially what we're doing, we're processing, we're applying a change to the outside of the function, the output of the function. So we're just taking the output of f of x and multiplying it by some factor. And the general rules then are, what happens is it results in a vertical stretch or compression, and the rules are if a is greater than 1, this a factor that we're multiplying by is greater than 1, then it's going to stretch it by a factor of a. And if it's between 0 and 1, then it compresses it. It compresses the function. Okay, now you just saw an example of a negative too. So that's a combination of transformations where we're stretching and reflecting. So you can see that that last example, we stretched the function by a factor of 2, but then we also reflected it across the x-axis by taking the negative of it. All right, I will meet you in the next video for the next exercise or next example.